make some Country Time lemonade, and we will definitely drink Country Time lemonade at some point, whether it's today, because I don't know, I have enough, but we'll see how much time we have to. So what we're going to do is we're just going to talk about solutions. We're going to touch a little bit on colligative properties, I think just to the point so that we can make ice cream, okay? So that we can make it relevant too. So we're just going to do a little bit of like, how do you make a solution? What does it mean? And you've seen this big M on different solutions that we've made. Anybody know what we call that big M? It's called something. There's a big M, and I'll say something like, it'll say 3M. And I'll say, oh, that's called 3, anybody know? Molarity. Awesome. 3 molar is what we call that. Perfect. It's called the molarity. So whenever you dissolve something in a liquid, you've made a solution. The liquid part is called the solvent, and then the stuff that you dissolved inside of it is called the solute. So if you have lemonade and you have water, water would be called the solvent, and then the lemonade, this sugary stuff would be called your solute. Okay? And if you forget it, the word solute is one less letter, so the solute goes into the solvent. Or if you say solute really fast a whole bunch of times, everybody try it. Go. Solute, 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 solute. It starts sounding like salt. And you would put the salt in the water. Okay? The universal solvent is water. So if you dissolve salt in water, salt would then be called your solute, and then the water would be the solvent. Awesome. And a handy rule of thumb is water's the universal solvent, so it's the most common solvent for solutions that you're likely to run into. You could use alcohols, though, and things like that as well. So when we're talking about how much of the solute's dissolved, we're talking about what is called the concentration, and you've heard this before. There are 4 terms that we use to describe concentration. There is what is called unsaturated. That means if you added more solute, it would still dissolve inside. Okay? You would still be able to get the sugar crystals to dissolve. It can be saturated. That means that the liquid has dissolved all the solute that it possibly can. And then there is what is called supersaturated. And supersaturated means that more solute has dissolved than is actually possible. And how can you do that? How can you actually dissolve more than what's possible? You heat it up. Awesome. You heat it up. You add, similar to if you've ever made Jell-O before, where they say it doesn't work in cold water. They say to make it in hot water, and then it cools down. Okay? And so it says if you have a very hot saturated solution and you cool it down, the solubility will then decrease as the solution cools. It says, in other words, hot solutions can usually dissolve more solute than the cold ones can. Typically, that's the way it works. What usually happens is the solute starts forming crystals at the bottom of the container. However, under weird circumstances where there are no little grains to start crystal formation, the crystals will never form. And then, as a result, your solution's more concentrated. So you can then add a crystal and the entire thing will crystallize. So one of the extra credit pieces is going to be making lollipops. And in lollipop making, you don't want the crystal to form. You actually want it to solidify before any crystals form. You can also make rock candy. Rock candy works in the opposite way. You do want crystals. So rock candy, if you've seen that, it looks like a whole bunch of little crystals, versus lollipops are clear. They look more glass-like. Okay. So when we'll talk more about the extra credit after this too. So molarity is a unit of concentration, and it's a numerical way of saying exactly how much solute did you put into your solvent. So it's equal to, what word are you seeing in your stem? Moles. Perfect. It's the moles of solute. And what you divide it by is how many liters you have of the solution. Liters total of the solution. So all you're going to do is you're going to take your moles of salt, you're going to divide it by your liters of solution, and you're done. So making a solution. It says you may either use the equation for molarity to solve the problems, or you can use bridges. All right? So we're just going to use this equation here. It's really easy to use. We have 59.5 grams of KBr, potassium bromide. We want to know how many milliliters of 2 molar KBr that we can make. Okay? So if we know that we have this many grams, guess what you need to do to the grams? Bless you. Convert it to moles. So we're going to take our 59.5 grams of KBr, we're going to throw in a bridge, cross our units opposite, and how do you get the mass? Yep, periodic table. So you're going to L chart it. And potassium is 39.1, and bromine is 79.9, and when you add them together, I believe you get 119.0 grams per mole. And then we're going to divide this, and you're going to tell me what you get when you divide. So please let me know when you divide this, what you get. 0.500, awesome. So 0.5 with 3 sig figs, we're going to say it's 0.500 moles of the KBr. We got the mole part, okay, but we don't want molarity in this case. We already have the molarity. So we're going to say 2.00 molar, so our equation is big M is equal to moles over liters by definition. So we already have the big M part. Now we can fill in our mole part, and it's 0.500 moles. So now what can I solve for? Liters, perfect. It's not milliliters though yet. Okay, we can convert it after. Anybody remember, so you can call that X. Anybody remember what I said about if you have an unknown, I have a trick. If you have an unknown in the denominator, how can you solve for it? Swap it, perfect. I call it the swap thing. So I'm going to swap this with this, okay? And then I get that my liters are equal to 0.500 over 2.00. And when you divide this, what do you get?
0.25.
0.25. Awesome. 0.25, and that's 3 sig figs, so liters. Awesome. 0.250 liters. But I want milliliters. Big E small. So if I'm going to a smaller unit, my number should get bigger. Awesome. So by how many places?
3.
1, 2, 3. Awesome. So 2.250 liters is 250 milliliters. Perfect. Okay, let's try another one. Milk of magnesia is that chalky liquid used if you have terrible stomach gases. Sorry if you do. The bottle states that there are 0.4 grams in 5 milliliters of solution. What is the molarity? So what are we looking for now? It's big M equals moles over liters. What are we looking for?
Big M.
Big M. Awesome. So do we know the moles? No, but we know grams. So let's do our grams over on the side here. 0.400 grams of this NgOH2. Don't forget you have to multiply the oxygen by 2 and the hydrogen by 2 when you do your L chart. So magnesium's 24.3, and each oxygen is 16.0, so that's 32, plus another 1 times 2 for the hydrogens, and that ends up giving us, I'll give you the exact answer, 58.3 grams per mole is what that gives us. Okay. So now I've got, does that sound right? Yes, that's right. Okay, so now we're going to divide this, and what do you get for the moles? 6, we want 3 sig figs, so 0.0, remember those zeros don't count? 0.0686, awesome, moles. So now we have our mole part, so I'm going to write that in there, 0.00686 moles. Okay, I don't have liters, but we have milliliters. What do you do if your unit's getting bigger? Your number should get smaller. So in that case, I'm going to take my 5.00 milliliters, and I'm going to shift my decimal in which direction? To the left. 1, 2, 3 to the left. What goes in these empty spaces? Zeros. Or you can divide by 1,000. So I get 0.00500 liters. Now what? Divide. Awesome. That's it. You're just going to divide. And we divide this. Tell me what you get. 1.37. Awesome. So that's called the molarity. All right? The more grams that you have of the substance, the more moles you will have, and you'll have a higher molarity per unit volume. Okay? Let's try one more. This one says, an experiment calls for 2 liters of a 1.5 molar KBr solution. You look in the supply room, and all you find is the solid stuff. How many grams of the KBr do we need? Well, if we're looking for grams, our equation is big M equals moles over liters. What part of this are we actually solving for that would give us grams? Awesome, moles. Once you get moles, then you can do a bridge to get grams. Okay, so let's work this out. Do we know the molarity?
No. Oh, yes, we do.
Yep, perfect. The 1.50. Awesome. So 1.50 M is equal to, do we know, we don't know the moles, that's what we're looking for. You can call it X, or you can just say moles. Do we know the liters?
Yeah.
Yes, 2.00 liters. How do you get moles alone?
Multiply.
Cross multiply. Awesome. Cross multiply these. Okay? So cross multiply, and you get that the moles are equal to 3. Perfect. 3.00 moles. That's not molarity. We already had the molarity, so that's just moles. So how do I get grams now? Throw in a bridge. Now moles are on the bottom, and grams are on top. Okay, so I need the molar mass of KBr. We already got that. It was 119.0 from that first problem. So all you're going to do is multiply these, and what do you get? 357. Now the question is, how do you make it? And this is where the lemonade stuff comes in. Okay? How do you make it? So you're going to do is, you're going to take, well, let's make the lemonade, and then we'll talk about it after. So what I have here is I have some Country Time lemonade. And typically what you do is you take your solid, your powder, okay? You add it, I put a little bit of water in here just because I wanted a little bit of extra. So I'm going to drop my solid into the container, okay? In our case, it'll be a volumetric flask, some type of flask, okay? Then what you're going to do is you are going to add water until you get the total volume that you need. And that amount that I put in makes 2 quarts. And so on my container, it says 2 quarts right up here. So I'm just going to add this until it gets up to, I add water until I get to the 2 quart line here. And then what do you do?
Stir.
Then you just stir it. Okay? So all we're going to do after that is just give it a nice stir. Now, this may be too concentrated for many of you. For my husband, it definitely would be. For me, I'd want more sugar. Okay? So I actually add a lot more. And then I tell him that he needs to do what to it?
Add more water.
Dilute it. Perfect. He pours his into a cup, and then he adds water to it. Okay? And he likes that done for my kids, but they like it the way I like it. Okay. All right. So we're going to keep it this way, and then I'll keep the water on the side, too, so that if you want to dilute it, you can. So I'll leave this over on the side, and then you can get a cup and get some after too. So we'll do that in just a little bit. Okay, so the last thing is, how do we make this statement? Okay, so to the statement of how to make it, what do you do first? You take the grams and you do what? Put them in a flask, container, some type of container, right? We're going to call it a volumetric flask. So place your 357 grams of KBr into a volumetric flask is typically what you use. And then what did we do to make the lemonade?
Add water.
Add water. Awesome. Add water until what?
You get 2 liters.
Perfect. Until you get the total volume that you want. In our case, it was quarts, because in the US we use quarts, but here we're using liters. Until the total volume equals 2.00 liters. That's it. Okay? Let's try one last one, and then we're done here. So your partner, Reckless Ralph, couldn't remember what concentration of KBr he made, but thankfully he remembers that he added 29.75 grams of the KBr to fill 1 liter of water. What's the concentration? They may write concentration. It's written in brackets. If you put something in brackets, that means the concentration of. Okay? So what are we looking for in this equation?
Big M.
Big M. Awesome. Looking for big F. So again, how are we supposed to get the moles?
You go from grams.
Yep, go from grams to moles. So 29.75 grams of KBr. Again, it was 119.0 grams per mole. So we're going to divide this, 29.75 divided by 119. And we get 0.250. Okay, awesome. 0.250 moles. Now what?
Now you set your up here.
Perfect. Set it equal to here, 0.250 moles, and divide it by 1 liter. It's 1 liter anyway. So if you have a liter of solution, then your molarity is however many moles that you have. So then we just get a 0.250 molar solution. Okay? So if you're looking at concentration, the more moles you add, the higher your concentration is going to be. Okay? And then what we'll do later on is we'll do how do you make the dilution. Because we'll talk about doing dilutions once you've made your solution and how do you do a dilution. Okay, and that's it for solution making.